Okay, for this example, for finding roots of quadratic functions with multiple methods and representations, we're going to use the following function. F of x equals 2x squared minus 6x minus 8. Okay, so first thing, taking square roots. And so f of x equals 2x squared minus 6x minus 8. Again, our first step is to set the function equal to 0. And the truth is, this really doesn't lend itself very easily to taking square roots. We don't have an isolated x squared term. We would have to, convert this maybe to vertex form and then take the square roots, and that just seems like a lot of work. So we won't be directly taking square roots here for this one. Again, you'd have to go through some steps to get it ready to do that. Doesn't make a lot of sense. So then let's solve by factoring. Maybe once we convert it to vertex form, we can try, but let's solve by factoring. So again, writing down our original function, and then setting it equal to 0. Okay, so remember, first step in factoring is always look for a GCF. Is there a GCF here? Greatest common factor. These numbers are all even. And so, yeah, there's a 2 that we can factor out or divide. So we could divide the entire function by 2, meaning both sides of the equation. 0 divided by 2 is 0. That's going to leave us x squared minus 6x minus 8. Nope. Minus 3x minus 4, right? Divide everything by 2. You have to divide every single term by 2. Okay. And then we can see if we can factor that. So is this factorable? And we would say, well, we've got x and x, two numbers that multiply to negative 4 but add to negative 3. If you use a diamond method, it's going to look like this. And you're probably coming up with negative 4 and positive 1. So we'd have x minus 4 and x plus 1. Remember, negative 4 and 1 are not our solutions. Our solutions are what we get once we use the zero product property. So we set both of these factors equal to 0 and solve for x. And x plus 1 equal to 0, solve for x. So our solutions are actually 4 and negative 1, not negative 4 and 1. Okay, 4 and negative 1. Then it says solve by graphing. Okay, well, to graph this, I know I've got a y-intercept at negative 8. I know my parabola opens up. I don't know what my vertex is. I've got to figure that out. So h is going to be negative b over 2a. And b is negative 6, so that's going to be positive 6 over 2 times a. A is 2, so over 2 times 2, which is 6 over 4, which is 3 halves or 1.5. So that's what h is going to equal. I'll make a little thing here for our vertex point is at 1.5. And then we have to put 1.5 into our function in order to find the k value. And so we'll put 2 times 1.5 squared minus 6 times 1.5 minus 8, and we'll solve that. You might want your calculator. 1.5 times 1.5, I know what it's going to be. It's going to be 2.25, but I just want you to know that's fine to use your calculator. So we get 2.25 times 2, and that's 4.5. 6 times 1.5, that's 1.5 sixes, that should be 9. Let's prove it to ourselves. Yep, 9, so minus 9, and then minus 8. 4.5 minus 9 minus 8. So k equals negative 12.5. Okay, so this is a weird one. This is a good one for us to think about how we want to scale our axes. So negative 12.5 actually won't fit on here. I'm going to have to replot that point. So let's let the x's increase by 1. So this would be 5. But let's let the y values be equal to 2. And so it would go 2, 4, 6, 8, 10, and negative 2, negative 4, negative 6, negative 8, negative 10. So that negative 12 would be here. And negative 12.5 is just a little bit less than that. We've got our h value at 1.5. And so we've got this point right about there. Is it perfect? No. Is it fine? Yes. We know that our y-intercept goes here, and that we know too that our stretch factor is 2 here. And so it's kind of hard to do this from these points. So this is a situation where even though we know how to use A to plot our point, we might want to go ahead and substitute in some values for x and use our rules of symmetry to plot some additional points. So we may need to, we know that our values are going to be 4 and negative 1. Let's just try that. If we plug 4 into our function here, we're going to have 2 times 4 squared minus 6 times 4, and then minus 8. And that should yield 0, okay? So that's going to be that value there. And then we also know at negative 1. So we can see on our graph, I gotta say, this is not a great one to solve by graphing, but that's fine. The other thing you can do is you can look in Desmos. So if you get a weird one like this, you can put it in Desmos, then sketch the graph on the axes, but then clearly label those points. Like clearly label where your vertex is. All right, and then clearly label your x-intercepts. Okay, so our x-intercepts again, our solutions are at negative 1 and 4, or 4 and negative 1. And then let's use the quadratic formula. Again, A here is 2, B is negative 6, and C is negative 8. Okay, a lot of negatives that we're putting into this formula, so we have to be really careful about simplifying when we do that. So we're going to start off with x equals the opposite of b. B is negative 6, so the opposite is 6, plus or minus the square root of b squared, negative 6 times negative 6, positive 36, minus 4 times a, which is 2, times c, which is negative 8. And again, we've got this minus minus here, so we're going to end up adding these two numbers together. But let's not forget our denominator here, 2 times 2. So first step is just clearly show your substitutions. All right, so we're going to have that equal to 6 plus or minus the square root of 36 minus 4 times 2 times negative 8. Which is 100. Okay, so we basically had 8 times negative 8 for negative 64. That becomes positive 64 plus 36, 100. Probably don't need this super long thing here. And then we'll divide that by 4. Okay, square root of 100 is 10. So this is going to become 6 plus 10 over 4, or it's going to equal negative 6 plus 10 over 4. 16 over 4. That's 4, versus this one's going to be 4 over 4, which is 1. Shouldn't this be negative? Oh, yeah. 6 plus 10, negative 6. Sorry, positive 6. That's where I made a mistake. Sorry, 6 minus 10 for negative 4 over 4. Can I just tell you how grateful I am for erasable pens? Okay, negative 4 over 4 is negative 1. So again, we have these solutions at 4 and negative 1. Okay, this is a nice thing about doing this in multiple methods too, is it's a built-in check for you to make sure that it works. All right, vertex form. We found out that h was 1.5. We found out that k was negative 12.5. We know that a is 2, so we're just going to write those values all in here. Factored form is kind of interesting here. So we know what the zeros are. P and Q are 4 and -1, or vice versa. It doesn't matter what order. And then we know that A is 2. And so we'll just write f of x. We'll plug in those values. Equals 2 times x minus 4 times x minus -1, which becomes +1. And then it's already in standard form, so we'll just rewrite it here. Okay, so that's 2 problems that both have real solutions. You'll have some others that have complex solutions, and I think I'll go ahead and do one of those problems as well for a third video. Oh, by the way, someone is so happy that we solved all this because it was a lot of work. Have you ever seen a skeleton dance before? Well, if not, now you have. Can you see that? Can you see the skeleton dancing? How exciting. Okay, great. Bye.